Let's write a program to find roots of a quadratic equation. So in grade 10 we would have studied quadratic equations. In a quadratic equation, for example, ax square plus bx plus c, a, b, c are the coefficient of x square, the coefficient of x, and the constant respectively. So the discriminant of this quadratic equation is b square minus 2ac, and we know that if the discriminant is greater than 0, then the roots are real and distinct. If the discriminant is equal to 0, we know that the roots are equal and real. And if the discriminant is less than 0, then the roots are imaginary. So let's get into the program. So we'll have to find the roots of a given quadratic equation. So in the main function, we will be prompting the user to input the coefficients, that is a, b, and c. Hash include stdio.h. Okay. We will have to include the math.h library as well. Include math.h. Now let's write the function void quadratic, and the parameters that it will receive will be of type float. Let's say type float. A, float b, and float c. Okay. Now if the value of a is 0, we also know that the formula to find the root is minus b plus or minus square root of the discriminant, whole thing will be divided by 2a, right? So now if this a value is 0, the whole thing becomes invalid. So that particular case we will take care by writing an if condition. If a is equal to 0, printf invalid. Okay. Now I will declare my discriminant int d is okay. Let's take a floating point value here as well. Float discriminant will be equal to b square minus 4ac. Okay. Now if d is greater than 0, printf the roots are real and distinct. I'll also include a new line character. Then printf, my format specifier for a floating point value is %f. So %f \n %f. Let me copy paste the formula. Minus b plus square root of d by 2a, comma. Now I'll copy this and paste it here and change this sign to minus. So this takes care of the condition where discriminant is greater than 0. So else if discriminant is equal to 0, printf the roots are real and equal, again I will include a new line character here, then printf percentile f backslash n percentile f here it will be minus b by 2a. Because the discriminant is 0, we can completely ignore that part of the formula. So it is minus b by 2a, and we can just write it again so that we'll know that there are two roots. So minus b by 2a. So this takes care of the case where the discriminant is equal to 0, and else, so this will be for d less than 0. Okay, so else printf the roots are imaginary backslash n, then printf percentile f plus I times percentile f backslash n percentile f minus I percentile f. Okay, so this is the format to write a complex number. So we will have two roots, so that one is minus b plus under root of b square minus 4ac by 2a. This will be the conjugate of that, comma minus b by 2a, comma square root of d by 2a, comma, now I can simply copy paste this, Control C, Control V, and we've missed an a here, so a and a. So this takes care of the case where the discriminant is less than 0. Alright, so now we will get into the main function. So int main, so let me first initialize the three variables, that is a, b and c. Float a, b, c, printf enter the values of a, b and c backslash n, scanf percentile f backslash n percentile f backslash n percentile f, comma ampersand, so a, comma b, comma c. Now I will call the function quadratic a, comma b, comma c, which are the passing parameters, and then return 0. So let me save and run this code. Okay, so enter the values of a, b and c. First I will enter 1, minus 7 and 12. Okay, so the roots are real and distinct. 4 and 3 are the roots. Okay, let me run the code again to just check with other values. Say 1, 2 and 3. Okay, so well, we have imaginary roots for this particular set of input values. So that's how this code works.